Hello and welcome to another video on the mathematical fundamentals from brilliant.org, this North American online educational platform for profits, founded by Sue Kim, or the co-founder was Sue Kim, and he presented that idea in 2011 to a series of venture capitalists and Jamat Palihapitiya, senior executive at Facebook from 2007 to up to 2011. He created a fund which is called Social Capital, which invests in companies like Slack and also Brilliant. The whole point of this is to recognize where this data come from, and especially where is the source of your knowledge, specifically these mathematical fundamentals. So in the first module, or let's gonna call this in the first section, we talk about generalize and how the value proposition of the mathematic is the practice of learning a lesson in generalize is the core of mathematics. So we look at a particular example or lesson right from the arithmos or the arithmetics, which is, after all, the arithmos come from the Greek word arithmos, which means count, and arithmetike or arithmetike, which can be translated to the art of counting, is something that I will invite you to apply that to your life, because this is something that I'm applying, especially, for example, how many time am I dedicating to learning, for example, mathematical fundamentals or computer science or Vue, Node.js, so how to build user interface, how to create server, and this is just a couple examples. You can also invest time or share time with your family, friends, mentors, dedicate time to your business, as well as your health. So this is the whole point of looking at this model, right, or at this course, is to the tools that I'm gonna learn from this, which is for this course is mastering skills like algebra, logic, and number theory. So how, by adding this spell, much like the League of Legends characters or Fortnite, right? So when you add this different spell, so pretty much is this. So this essential toolkit that I'm going to master as a way to apply into my life. So I will invite you to do that as well in your life, and you will see how remarkable and how powerful is this abstract concept when you apply that and you see over time. In any case, so generalize the value proposition of the mathematic is that, and the mathematicians, so the value proposition of the mathematician is that they practice actively generalizations based on lessons learned. So here I look at the particular examples from the arithmos, okay, or the arithmetica, or these operations on numbers, and see how a particular pattern and how can we use that pattern to generalize using algebra. So the keyword here is pattern. So for example, if I ask you, so what is the sum of the first n odd number? What is the sum of the first 5 odd numbers? So you might say, okay, 1 plus 3 plus 5 plus 7 plus 9. So instead of calculating each one of them, using visualization and using geometry, we reach a conclusion that if you want to know quickly the answer of that question, so we don't having to do the actual process, okay? So you have a generalization or a formula, okay? An equation here, especially a formula, and that is m power 2, meaning that without having to calculate this, we can know straightforward what is the value of the first odd numbers. So 5 power 2 is 25. So that's the beauty of this. And then I look another concept or in the another section, which is rewrite, rethink, and redraw, and how by looking the patterns of the mathematical fractions, such as fractals, which are the mathematical fractions less than 1, and how a beautiful pattern arrives, the fractals, and the mathematic of fractions over 1, compound interest. So again, by using geometry, so we were able to see two particular patterns in real life. Okay, one of them is the Sierpinski triangle. Okay, and how by multiplying. So if we think number as shapes, okay, a triangle, for example, or a square. So if we think number as shape, we can say that if you multiply by a fraction less than 0, okay, it which is something that I'm doing here. What is this? Okay, the value proposition of this. So multiplying a fraction less than 0, it remove chunks in a regular way, smaller each time, ultimately producing this fractal at the end. So this fractal, let me see, is this fractal, fractals like this, right? This is another example I would like to use is the Sierpinski triangle. Okay, Sierpinski triangle like this. All right. Exactly. The Sierpinski triangle. Let me see if there is some sort of animation here. Yep, the Sierpinski triangle. Yeah, but there is no. Well, this is a great example of this animation. So if we think our number as shape, okay, and multiplying by a fraction less than 1, remove chunk or remove chunk in a regular way, smaller and smaller each time, ultimately producing how fractals, a hollow fractal, yeah, ultimately producing a hollow fractal at the end. So you might wonder, why would I need to actually, why do I care about this? You know? So for example, if you now, let's say, you want to think your life as a shape, as a triangle, where this triangle, you allocate your time is on family. So for example, like this. Okay. So for example, in relationship, business, and health. All right. And how by each one of them you multiply by a fraction less than one, remove chunks remove chunks in a regular way. So it removes chunk in a regular way. So you can it removes chunk in a regular way. Exactly, it removes chunks in a regular way, smaller each time, ultimately producing a fractal, meaning that you can, each time you're multiplying uh, by a fraction less than zero, you can here now dedicate its time to things that or you can allocate time to things that are important for you. So your family, friends, mentor, career, finance, assets, fitness, nutrition, and meditate. You know what I mean? And after all, so what you're doing is, yeah, that's right. Here you're taking away a huge portion of this time. Uh, the whole point of this is to see how you can apply this particular pattern to your life as a way to test this mathematical concept, and which mathematics come from the word mathema, learn, or the mathema is actually what it also means is one once gets to know that which is learn, you know. And from this, what you can learn from this is see how you can apply it to your real life, and especially when you allocate time to a different aspect in your life. So this is a fractal, okay? The value proposition of this course, or at least this model, when we talk about rewrite, rethink, and redraw, is look at these two patterns in the mathematical fractions, the fractals. So when you multiply a fraction less than 1, it removes chunks in a regular way, smaller each time, ultimately producing a hollow fractal. However, when it comes now to multiplying, so if we think of numbers, if we think of unit, we can also look at this as unit of time. So if we think our shape, or if we think numbers as shape, and we multiply that by yeah, and we multiply that yeah, and we multiply that by fractions over 1, it add regular chunks. So it add smaller chunk, because after all is that it add chunks in a regular way, bigger and bigger each time. So each time you multiply that, ultimately growing into an infinite in an exponential way. So a great example of this is the compound interest, is how you will earn along the way once you dedicate time to a particular task. Okay, so this concept from the compound interest, okay, which make heavy use of the arithmetic of fractions, okay, I would like adding fractions, okay, so adding fractions, or yeah, adding or subtracting fractions to a whole number, multiplying a whole number to a fraction, okay, and that kind of thing. So especially with this particular concept, the compound interest, we can see is how, again, if we think number as shape, multiplying by a fraction greater than 1, it adds chunks in a regular way. So every time you multiply by a fraction greater than 1, so it adds chunks in a regular way, bigger and bigger each time, ultimately growing into an exponential. So ultimately growing to infinite in an exponential way. So these two powerful concepts is something that either way I am applying. This is a testament of me actually doing the work, specifically with the compound interest, as a way to improve my foundational mathematics. If I need to solve someone else's problems, first myself, my own problems, and then someone else's problems, now we can talk. Okay? Now we're talking. And now mathematics are fun after all. So that's great. That's interesting. Totally, totally. Now, with that, okay, which after all it was beauty, because with the compound interest, now we look at these two patterns, and something that they mention here, that this is a duality that happened a lot of in mathematics. In when they talk about here, for example, starting with review the lesson. Okay, so this duality, no, here, this duality, oh, come on, really? No, but this duality is this. So you have faced fractal and investment. Now we get to the elephant. Imagine you have heard an elephant before when you are encountering water in the corner of your room. Unfortunately, you have forgotten your glasses. So you're going to have to touch the elephant to work out what it looked like. What will you come up with? You might think that one small part of the elephant feels like a tree, or maybe like a rope. You wouldn't be wrong, but you only seen one part of her. For every concept in mathematics, there is always more to learn if you change how you look. And this is the value proposition of this course. Okay? So changing value proposition math perspective. So changing your perspective is something they're going to write it down. So changing your perspective is a powerful, yes, changing your perspective is a powerful problem solving technique in math. Often, exactly. So changing your perspective is a powerful problem solving technique in math. Often, often the right perspective, exactly, the right perspective can make a difficult problem suddenly straight suddenly straight forward. But that's the whole value proposition of this section. Okay? Math perspective. So now that we're able to see is the mathematical fractions less than zero and how a particular pattern arrives using geometry, as well as the mathematical fractions greater than one, less than one. So I look at the I look at the so we look at the fraction of the mathematic. Jesus. So we look at the pattern that arrive from the mathematical fractions less than one, called fractals, and by using visualizations, how by multiplying a fraction less than one, remove chunks in a regular way, smaller and smaller each time, ultimately producing a hollow fractal. And another pattern, okay, which is the mathematics of fractions of greater than one. So when you multiply, so if you think your number as shape, multiplying by a fraction greater than one, it regular or add add chunks in a regular way, bigger and bigger each time, ultimately growing to infinite in an exponential way. So the whole point of this rewrite, rethink, and redraw, right, is to recognize this duality nature in the mathematics or in the world, in the real world, okay, and how by changing your perspective in math is a powerful problem solving. So how by changing your perspective in math is a powerful problem solving technique that can often, with the right perspective, can make a difficult problem straightforward. And that's the beauty of this. That's the beauty of this. Totally, totally, totally. Okay, okay. Cool, cool, cool. So, this kind of duality is the first of many that you will encounter in this course. And keep an eye on it. We use Sierpinski triangle fractal to visualize neatly, finding 1, 4, and phi 4 on initial value, and we found that it takes only 3 years for an investment to double. And this is also a pattern here, especially in the finance, with the rule of 72. How much it will, using the compound interest concept, how much time it will, how much time, or how can I increase my money, all right? Talking now in the terms of money, how can I increase my money? How can I double my money? So, or how long will it take to double my money? And here, that is a very interesting question. So, that's where it comes the rule of 72. Rule of 72. Okay. So what is the rule of 72? And this is a Quicklis formula that is popular, used to estimate the number of years required to double the invested money at a given annual rate of return. Alternatively, it can compute the annual rate of compound return from an investment. So The formula that is popularly used to estimate the number of years required to double the investment money and a given annual return. So, for example, okay,
will take your money to double. For example, if Aaron puts $5,000 in a blue chip stock with an annual return of 2%, his investment will grow to $10,000 in roughly 36 years. The formula can also help illustrate the effect of inflation and expenses. For example, if Aaron expects the long-term rate of inflation to be 3%, any savings he doesn't invest will lose half its value in 24 years.
Interesting. Division.
Value in 24 years. The rule of 72 is most useful for providing a quick, general idea of how compound rates affect money.
And this is something interesting. This is a quick general idea on how compound interests affect money. So with this given formula here, okay, and this is one of the cool thing of the algebra, right? So with this formula, with this generalization, now we can solve a particular problem, and this is how much money it will, how much money it will, how much time my money, or how can I double my, yeah, how much time will, so how much time it will take me to double my money, or how much time will take me to double my money. So if I want to know is, for example, 1 year, okay, so I need to invest 72%, or I need to find something that gives me 72% annually. Where are the things that you can invest 70% annually, or where are the things that you can get is the most out of it? So for example, using if you think your time as a fraction here, so 72% of your time, so how can you actually get the most of it? So you can use this a formula called is, or not a formula, is the Pareto principle, okay, the Pareto principle, like this. So this Pareto principle, described by an Italian economist, Vilfredo Pareto, established that 20% of the 80% of the result come from 20% of interest. 80% of the result comes from 20% of the effort. So the whole idea is to apply each one of those concepts in your daily life and see what is the outcome that you're getting from that. Okay? So with this rule of 72, it's an easy way to tell you how much money it will, how much time, or how can double my money, how much time it will take to double my money. So how much time it will take to double my money. That's what it is. That's what it is. And that makes a lot of sense. Yep. Yep, completely. So, so we can look at the next model here, okay? And before that, okay, I just wanted to summarize this, okay? So this is the value proposition of this course, is math perspective. So the value proposition of the first section, which is generalized, is patterns, okay? The second section of this course is perspective, math perspective. Okay? And here we are, thinking forward and backwards. To solve new problems, you need to be able to think in several directions. So that'll be all for this video. Then take care. Bye-bye.